all that online multiplayer is a bunch of single-player games that are syncing state with each other. So when in a single player you have a single copy of the game running, in a multiplayer game you will usually have at least 2 copies of the game running and constantly syncing state with each other so that they create a shared experience for both players. Speaking of syncing state, what is that? So presumably in your game you're going to have some kind of state that is important to the simulation of the game, such as the player's health or the player's position in the world, right? If you have no health, you might be dead. If you have 100 health, you can still move. So these are important to the outcome of the simulation. So you would send it over the internet in the form of a data packet to player 2, and player 2 would do the same. That is synchronizing state. Now, one problem you're going to run into when you're syncing state is authority. What happens if we have a disagreement between player 1 and player 2 about what happened in the simulation? So let's say player 1 says, I just hit you. But player 2 says, no, actually you missed me. So in this situation, we would have to decide who is the authority and whose information is going to be the quote-unquote source of truth. If we make player 1 the authority, then we agree that he hit player 2, even if player 2 disagrees. Now this is where dedicated servers come in, which is a different network architecture that you can use, where instead of just running one game copy on player 1's machine, another copy on player 2's machine, you start an additional game copy on a machine that you have access to and only you, so that it can simulate the game just the same as player 1 and player 2. But when there's a disagreement, the server or the dedicated server would come in and say, actually, player 2 is right, and then that becomes the source of truth. Now, the advantage of the dedicated server approach and why so many games use it, like League of Legends, Overwatch, is the fact that it is built into it inherently is the ability to fight cheaters. Because that game copy is running on a machine that only you have access to and no other player, that makes it so they can't tamper with it. But if you make player 1 the authority, all of a sudden he can tamper with his own machine. He can say, well, I hit you, even though he knows he didn't hit you, but he's cheating. But what's important to understand is that at the core level, that's all it is. You're just starting up an additional game copy on an additional machine, and you make that the authority. But you can skip that, and you can make player 1 or player 2 the authority. And in fact, that is the recommended path for a beginner, for an indie developer, because then you don't have additional costs. And let's be honest, in a small game, it's not that important. Once we solved the authority problem, we're going to run into the problem of network latency. So when player 1 sends messages to player 2, because they send them over the internet, they're not instant. So if player 1 sends a message to player 2 and it takes 30 milliseconds to get there, we would call that network latency. When player 2 sends a message back, a response to player 1, that would be another 30 milliseconds. And that is network latency times 2, or sometimes called one-way time. So 30 milliseconds times 2 is 60 milliseconds. That's our round trip time. And in popular game culture, this is known as ping. So if you play something like League of Legends, at the top left screen, you can usually see this number called ping. If you see 60 milliseconds, it takes 30 milliseconds for you to send a message to the Riot Games server, and then another 30 milliseconds to get a message back. Why does this matter? It's only 30 milliseconds after all, at least in the example I gave. Why would that? Can't we just ignore it? Let's imagine an example where player 1 shoots a bullet at player 2. Now, if he has a network latency of 30 milliseconds, that means what he's really shooting at is the player 2's position that was 30 milliseconds ago, because he doesn't know where player 2 is at the moment. He can't know that. So that's problem number one. But problem number two is also with authority. If player 1 is not the authority and player 2 is the authority, then when I shoot the gun, I don't actually know if I was allowed to shoot it. Did I have enough ammo? Was I maybe dead already? Maybe player 2 stunned me right before I took the shot. In this scenario, we would have to send a message to player 2 asking, am I allowed to shoot? And then wait for a response, which is another 30 milliseconds. So you can imagine that 60 milliseconds delay can be pretty annoying for player 1 every time he wants to take a shot. Furthermore, my example always says 30 milliseconds, but you might want to support players that have really bad network connection and maybe their ping is 100 milliseconds. Maybe it's 200 milliseconds. So now that we understand why it matters, how do we fight it? There are many different tricks and techniques, and I'm definitely not going to mention them all, but I will mention what I consider to be the bread and butter, the most important ones. And if you just know these techniques, you can definitely make a multiplayer game. You don't have to know anything else. One technique we could use is input delay. If we go back to our example, when player 1 shoots a bullet at player 2, instead of immediately processing his inputs, we could inject a little delay on purpose. So when he presses shoot, instead of immediately processing it, we're going to wait, let's say, 2 frames, which in a 60 frames per second game would be roughly 32 milliseconds. So we know he pressed it, we know he pressed the button. We're going to immediately send this message to player 2 that I took a shot. And on the local machine of player 1, we will wait 32 milliseconds. And if our network latency or one-way trip time is 30 milliseconds, that means we just effectively solved latency for this specific case. So by the time player 1 will execute this command of shooting, player 2 will already know that player 1 is shooting at him. And both players will see the same thing on their screen at the same time. Then we have prediction. If we use input delay to cover some of the latency, what we can do with the remaining latencies, we can use prediction. Once again, going back to the player 1 shooting at player 2 example, and the problem of authority that I mentioned, instead of player 1 waiting to send the message to player 2, who is the authority, and asking him, can I take this shot? Am I allowed? Do I have enough ammo? And getting a message back, we can instead validate this request on player 1's machine. Does he have enough ammo? Is he still alive? And if the answer is true, if we believe he can shoot, we could predict that player 2 will agree with our decision and just shoot immediately. This way, for player 1, it feels really responsive because the shot goes immediately. Then if player 2 responds to us exactly how we predicted and says, yes, you were allowed to take the shot, we're good. Of course, the downside to this is if player 2 responds with, no, actually, right before you took that shot, I stunned you, so you were not allowed to take the shot. Now we're going to have to reconcile. We're going to have to fix our game simulation to match what the authority said, essentially. Remove the bullet, remove maybe the damage that we dealt to player 2. It depends. The more you try to predict, the more things you might have to fix after you predicted wrong. So prediction is a very broad topic, and you can predict as many things as you want in the game or as little as you want. Your prediction can be very sophisticated or very simple. If player 2 is moving to the left and you know he's been moving to the left for the last couple frames, even if you don't know what he's doing now, you could predict that he's still moving to the left and make the game feel more responsive that way. But of course, sometimes you're going to be wrong. So that's the downside. And then we have interpolation, which is really more about the visuals. If we only update the player's position every 2 frames, that's going to be visually, that's going to look quite choppy because our character is moving every single frame, but player 2 is moving only once every 2 frames. So it's going to be twice as choppy as our own character. It's not going to look as smooth visually. What interpolation does is you can take the last known player 2 position, take the position that we just received from player 2, and instead of immediately snapping it to that position, we're going to cover half the distance in one frame and then another half in the other frame. And this makes it so player 2's movement looks a lot smoother. So these are the 3 tactics I would recommend for a beginner. So to recap, a multiplayer game is just a bunch of single-player games syncing state with each other. And when it comes to syncing state, we have to ask ourselves, what data do I need to send? So as we discussed, it's like player position, health, whatever is important to keep the 2 games in sync. How do I validate it? That's the question of authority. So who is the authority? And finally, we need to fight network latency. If you know only what I just laid out, believe it or not, you are ready to make an online multiplayer game. Just gotta start. And yeah, thanks for watching and have a great day.